Hello everyone, my name is Dang Xue. I appreciate the opportunity to be with you today. I am now to start my presentation for Calculus 1. We are here to discuss and sketch the following function. These are the 5 important steps that could help in solving and sketch the function. The first step is to find the x-intercept and the y-intercept of the function. To find the y-intercept, we set x equal to 0. Then, we found that the y-intercept in this function, which is x equal to 0 and y also equal to 0. To find the x-intercept, we set the y equal to 0. Then, we found that there are 3 x-intercepts in this function. First is x equal to negative sub 5 and y equal to 0. Second, x equal to 0 and y also equal to 0. The third one is x equal to sub 5 and y equal to 0. The second step is to find the open interval where the function is decreasing and increasing. We use the first derivative to determine where the function is decreasing and increasing. So, let the first derivative equal to 0. We test the value on all sides of this to find whether the function is decreasing or increasing. The test number is negative 2, negative 1, 1, and 2. Substitute all the test number into the first derivative. Since the value is positive, when x equal to negative 2 and 2, it means that the interval is increasing from negative infinity to negative 3 and from the positive 3 to positive infinity. While the value is negative when x equal to negative 1 and 1, it means that the function is decreasing from negative 3 to positive 0 and from the positive 0 to positive 3. The third step is to find the x-coordinate of the inflection point. After that, we use second derivative to find the x-coordinate of the inflection point. We let the second derivative equal to 0. Hence, the x-coordinate of the inflection point is equal to negative 3 over 2, 0 and positive 3 over 2. The fourth step is to find the open interval where the function is concave up and down. After that, we use the second derivative to determine whether the function is concave up and down. Set the second derivative equal to 0 and solve it. Then, the second derivative is defined for all the real numbers, so there are no other x value added. Thus, the complete list is negative 3 over 2, 0 and positive 3 over 2. Next, we plot this number on a number line and test the region with second derivative. We use negative 2, negative 1, 1 and 2 as the test number. Then, we substitute the test number into the second derivative of the function. The positive sign on the sign graph means the function is concave up in the interval. In contrast, the negative sign on the graph means the function is concave down in the interval. Hence, the function is concave down in the interval from negative infinity to negative 3 over 2 and from 0 to positive 3 over 2. And the function is concave up in the interval from negative 3 over 2 to 0 and from positive 3 over 2 to positive infinity. The fifth step is to find the local minima and the local maxima of the function. After that, we use the first derivative to find the local minima and maxima. So we let the first derivative equal to 0. The root of the first derivative is negative 3, 0 and positive 3. Then we substitute the roots negative 3, 0 and positive 3 into the function to find the point of local minima and maxima. Hence, the local minima is negative 3 and the local maxima is positive 3. After finishing the 5 important steps, we can start to sketch the graph. This graph is sketched by the 5 important steps that we have found. That's all for my presentation. Thank you.